Hello students, welcome to mathematics class. Students, this is part 4 of the chapter Exponents and Powers. In this part 4, we will see use of exponents to express small numbers or very large numbers in standard form. Now, coming to the important facts, let us observe these facts. The distance from the earth to the sun is, here could you read this number? This is not a very huge number. Suppose if you want to read, it will be read as hundreds, thousands, millions, billions. So 149 billions, 600 million meters. Then the speed of light, it is 300 million meter per second. Thickness of the class 7th mathematics book, 20 millimeter. The average diameter of red blood cell is 0.0000007, that means 0.507 millimeter. The thickness of human hair is in the range of 0.005 centimeter to 0.01 centimeter. The distance of moon from the earth is 384,467,000 meter approximately. The size of a plant cell is 0.00001275 meter. The average radius of the sun, so average radius of the sun is somewhere around 6,95,000 kilometer or 695,000 kilometer. Mass of propellant in space shuttle solid rocket booster is 503,600 kg. Then coming to the thickness of a piece of paper is somewhere around 0.0016 centimeter. These are some of the facts. Continuing further, diameter of a wire on a computer chip is very small, 0.00003 meter. The height of the Mount Everest is 8,848 meter. Now observe that there are few numbers which can read like 2 centimeter, 8,848 meter, 6,95,000 kilometer, but there are few some other large numbers like you have got 150 billion meter and some very small numbers such as 0.507, that is 0.000007 meter. Now when we have some large numbers or some small, very small numbers, we represent them in standard form that we have already learnt in class 7th. Identify in this list of 12 facts which are small, which are big. Okay, as a table Very large number you have to identify and very small number you have to identify. This is your work. Let us come to this back. First one, here it's large number. This one again large number. This one small, not very small. This is very small number, and these are also small numbers, and this is large number, and it's very small number, and it is large number, and this is again large number, and this is very small number. Amongst this 11th and 12th, this is very small number, and this is big number or large number. So, we could classify these 12 facts into very large number and very small number. After that, we will make this table. You do it, this is your work. Now, coming to we have learnt how to express these large numbers as well as very small numbers in standard form in your previous class. Children, very important, what is standard form of a number, or how to express very large number or a very small number in standard form? You need to recollect. For your help, I am telling you, whenever you have got a very large number or very small number, we express as k into 10 to the power n form. So, a number very large or very small expressed in the form of k into 10 to the power n will be called a standard form, where here k should be less than 10 but more than or equal to 1. That means it can be 1 or more than 1, but should be less than 10, and n is any integer. N is any integer. So, these are the conditions. Now, for example, you have got 150 billions, where ones, tens, hundreds, thousands, 10,000s, 100,000s, million, 10 million, 100 million, billion, 10 billion, 100 billion. So, we normally read 150 billion, but every time it is difficult to write it. In short, how can it be written? Means it is written as 1.5 into 10 power 11. Now, question comes, how could we got this 10 to the power 11? Okay. So, how this 10 to the power 11 has come, let me explain you. But before that, standard form of a number, meaning I have already said, you can note down this passing the screen. A number expressed in the form of k into 10 power n, where k is a number lying between 1 and 10 and n is any integer. So, this you note down. I will wipe out the screen. Now, coming to the how we have got, this is the reason. Let me explain. You have got 150 billion where point is here. So, this point I am shifting it for 11 times. You can watch how it is shifted. So, once, twice, thrice, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, 11 times. So that this 150 billion becomes 1.5 into the 10 multiplied by itself for 11 times. So 10 multiplied by itself for 11 times will be expressed as 10 to the power 11. So where are we shifting? The decimal point is getting shifted to the left side of it. How many times it has shifted? 11 times it has shifted. That will give power of the 10. Okay. So this is the way what we have done in your class 7th. So expressing very large number in standard form and very small number. How can we express this very small number in standard form? Here 0.507 meter, if you want to express, you will express this procedure, you will adopt 0.507 can be written as 7 upon 10 lakh, and this 10 lakh can be written as 7 upon 10 to the power 6, because 10 lakh contains after 1 6 zeros, which is 10 lakh. One way we can write 10 multiplied by itself for 6 times. So we express that 10 multiplied by itself for 6 times in the power or in exponential form. So 7 upon 10 power 6, where this 10 power 6 using earlier knowledge can be taken to the numerator with the power negative. So 7 into 10 power minus 6. Is this is in standard form now? Yes. So we can write now 0.507 meter as 7 into 10 power minus 6 meter. So this is the standard form of representing very small number. Reason of doing I explained, but is there any shortcut like this? Yes, there is a shortcut. Here I am explaining. See, when I am expressing very large number, we shift decimal point to the left of it, whereas when we are writing very small number in standard form, we shift point from it to the right side. So we will shift to the right side of that point. So how many times you will shift? That will become power, but with minus sign. So minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So 6 times we shifted with a negative power. So minus 6 will come. So this is the shortcut. So both are very important, expressing very large number and very small number in standard form. This is your previous learning. Now similarly, consider the thickness of a piece of paper. Piece of paper will not be normally 0.0016 centimeter. Now if I want to express this in standard form, I have to shift point from here once, twice, thrice. So it becomes 1.6 into 10 to the power minus 3, because I shifted thrice. So from the point we will shift right side of the point once, twice, thrice. So then it becomes 1.6 into 10 to the power minus 3. See, this is the procedural steps. 16 upon 10,000. 10,000 is nothing but 10 to the power 4. 16 by 10 power 4, where 16 is can be written as 1.6 into 10. So after simplifying, 1.6 into 10 into 10 power minus 4 becomes 1.6 10 to the power minus 3. But shortcut I have already explained. When we are moving decimal point from that point to the right side, how many times we have shifted, that many negative powers or that much of negative power we will write to the 10 in standard form. Now coming to the, therefore thickness we have already got, and let us coming to the solving, try these questions. Write the following in standard form. Coming to the question number 1, in main question 1, I have to shift to this point. So once, twice, thrice, 4 times, 5 times, 6 times, 7 times. So then it becomes 5.64 into 10 to the power minus 7 times. So 1, 2, 3, 4, 5, 6, 7 times I have got. Okay, same way second question. In second question, I will have point shifted 1, 2, 3, 4, 5, 6. 6 times, so it becomes 2.1 into 10 to the power minus 6. Whereas question number 3, it has 2, 1, 6 and after that 5 zeros are there. If you want to read, you can read it as 2 crore 16 lakh. This 2 crore 16 lakh, where point is here, it's supposed to be shifted for once, twice, thrice, 4 times, 5 times, 6 times, 7 times. So it can be written as 2.16 into 10 to the power plus 7. Remember, very large number will have the power of the 10 being positive, very small number will have power of 10 being negative. So coming to the question number 4, 1, 5, 2, 4, 4 zeros. How do you read this? You will read it as 15,240,000. So if you want to write it, it becomes 1.524 into 10 raised to the power. So from here, shifting point here takes place 1, 2, 3, 4, 5, 6, 7. So 1.524 into 10 to the power 7 will be the standard form. Here, how many digits are there? 1, 5, 2, 4, 4 digits and 4 digits, 8 digits are there. So number of digits, if it is having 8 in a large number, then the power will be 7. Here how many digits are there? 2, 1, 6, 0, 4 and 4 zeros, total 8 decimal, 8 digits are there. So power of 10 while expressing this large number will be 7. So this is another way of cross checking. Write all the facts given in the standard form. So you have to go back, that 1 to 12 facts you have to write it in standard form. You can do it in your textbook, do it as a homework in textbook itself. Okay, that is your work. Now coming to the comparing very large numbers and very small numbers. So we easily can compare these very large numbers and very small numbers based on the power of 10. Now watch, the diameter of a sun is 1.4 into 10 power 9 meter, whereas diameter of the earth is 1.2756 into 10 to the power 7 meter. Now which is bigger? Is sun is bigger or earth is bigger? Certainly sun is bigger, because the power of 10 is 9, which is bigger than power of 10 is 7. So that is how we compare. Suppose you want to compare the diameter of the earth with the diameter of the sun, you will see this way. Diameter of the sun is 1.4 into 10 to the power 9 meter, diameter of the earth is 1.2756 into 10 to the power 7 meter, and if you compare, definitely approximately sun is 100 times the earth. Okay, because of the 10 power 9 difference with the 10 power 7, you will have 100 times. Okay, here is the procedural way of checking. Now coming to the, so the diameter of the sun is about 100 times the diameter of the earth. Now let us compare the size of a red blood cell, which is 0.507 meter, to that of a plant cell, which is of 0.401275 meter. First we will write them in standard form. You know, 0.507 meter is written as 7 into 10 power minus 6 meter, and red blood cell, plant cell is of 1.275 into 10 power minus 5 meter. Now you cross check them. When you are comparing, if you take the ratio of them, certainly you have the ratio being 1:2. So what does it say? So the red blood cell is half of plant cell. Why? Because if you have taken red blood cell on numerator and dividing with the size of a plant cell, you are getting only half. So definitely the red blood cell is smaller. By cross seeing these negative powers, minus 6 is smaller than minus 5, definitely minus 6, 10 to the power minus 6, whichever is the red blood cell is smaller than the plant cell. So size of the red blood cell is half the plant cell size, okay, approximately. Anyways, the procedural way I have explained, you can pause the screen and go through it carefully. Now coming to the mass of the earth. Mass of the earth is 5.97 into 10 to the power 24 kg, whereas the mass of the moon is 7.35 into 10 to the power 22 kg. Now you know which is bigger? Obviously earth is bigger, but what is the total mass? You are asked to find the total mass. See, when you are adding or when you are doing operations on numbers in standard form, there must be first converting them with the same power of tens, that is 5.97 into 10 to the power 24 kg plus 7.35 into 10 to the power 22 kg. We cannot do it directly. So first what we have to do, convert numbers with the same power of tens. So 7.35 into 10 to the power 22 kg, we will keep as it is. This 10 to the power 24 kg can be converted into 10 to the power 22 by splitting 10 to the power 24 as 100 into 10 to the power 22. 100 into 10 to the power 22 gives again this 10 to the power 24 only. So 5.97 into 100 gives 597 into 10 to the power 22. So with the same powers of tens, now we can add them. So it becomes, taking 10 power 22 as common, so 597 plus 7.35 gives 604.35 into 10 to the power 22 kg, being the total mass of the earth and moon. So this is the very important instruction. When we are adding or doing subtraction, any operations, we convert them into the numbers with the same exponent of power 10 or exponents to the 10. Then we will do one more question based on the same concept, operations on numbers of the standard form. Okay. Now another important operation we will do, the distance between the sun and earth is given, that is 1.496 into 10 to the power 11 meter, and the distance between the earth and the moon is given as 3.84 into 10 to the power 8 meter. You know which is far. So the distance between earth and sun is far or more than the distance between earth and moon. Because of this 10 power 11 and 10 power 8, we can compare and say, during solar eclipse, moon comes in between the earth and sun. During solar eclipse, we will have moon coming between earth and sun. At that time, what is the distance between moon and sun? At that time, what is the distance between moon and sun? That means it's a straight line. Okay, on a straight line, we have earth and we have sun. In between sun and earth, we got a one small moon coming. So now we need to find distance between moon and sun at that time during solar eclipse. So distance between sun and earth minus distance between moon and earth becomes the distance between sun and moon. So difference between these two numbers I have to find out. So distance between sun and earth, distance between earth and moon, and obviously we need to find difference, subtraction operation. But before doing subtraction operation, I know I must take power of the same. Now the difference, if you want to find out, compulsory you need to make to the power of same 10. So this 10 power 11 can be written as 1000 into 10 power 8. This 1000 after multiplying with 1.496 it becomes 1496 into 10 to the power 8. Now 10 power 8 can be taken common. So therefore 1496 minus 3.84, it is approximately 4. If you remove, it becomes 1492.16 into 10 power 8 meter. This is the distance between the sun and moon. So children, we have seen enough of the examples for the operations and standard form of numbers. Now let us go for exercise or example questions from the textbook. In example number 8 of the textbook, we are given express the following numbers in standard form. So first one, 0.4035. So I will write this as once, twice, thrice, 4 times, 5 times. So I will write it as 3.5 into 10 to the power minus 5. I have shifted from the point to the right side of it for 5 times. So I have got minus 5 as the power of 10. Coming to the question number, sub question number 2, 4050000. It is a big number, large number. So power should be positive, and here point is in here. And how do you read this number? If you are reading this number, you will read it as 4,050,000, or if you are reading in Indian system, you will read it as 40,50,000. So point is shifting from here once, twice, thrice, 4 times, 5 times, 6 times. So 4.05 into 10 to the power 6. Here positive power will be there because it's a very large number. So with this, next we have got example number 9. Example number 9 is having again 3 sub questions. Let us solve one by one. Sub question 1, express the following numbers in usual form. So 3.52 into 10 power 5, that means 3.52 is to be multiplied by 1. After that we have got 5 zeros, that means with 1 lakh we have to multiply. So points will be shifted. So how many times point will be shifted? So point will shift once, twice, but when we are multiplying, the number will be keep increasing. We are multiplying with the powers of tens with positive. So it becomes 352 into 1000 now, because for 2 zeros I have shifted, and now it becomes 352 besides 3 zeros. That means it is 3,52,000. And question 2, 7.54 into 10 to the power minus 4. That means it's very small number. So point will be shifted from right to left. Here it can be written as 7.54 upon 10 power 4. That means we will divide 7.54 upon by 10,000, where point is shifted from here once, that means 0.754 by 1 0 goes out, and by 1000. If you want this dividing this number still further 1000, so point has to shift. So 75410, when it is shifts here, one more 0 when it shifts to one more place, and one more 0 when it shifts to one more time. So total 0.30754 will be the value of 7.54 into 10 to the power minus 4. To make it a short, I will give you one small hint. Remember, what is the power? It is minus 4. Remember, the decimal point and first non-zero number in between them, from the decimal point or between the decimal point and non-zero decimal number. So between them you will have 1 less than this number. 1 less than 4 is 3, so 3 zeros will be there. So this is one more hint. For example, in the case of third, 3 into 10 power minus 5. That means I have a 0 point and 3 being non-zero digit. Between them I will have 1 less than the 5 digit, 1 less than the 5 many zeros. That means 1, 2, 3, 4 zeros. That's it. If you want to cross check, you can check 1, 2, 3, 4, 5. 5 times it has shifted, so minus 5 has come. So this is how we do it. Even when there is negative power, easy to identify how many zeros will be there between decimal point and non-zero number, decimal number or decimal digit. So this is how we solve standard form of numbers and operations on standard form of numbers. So with this I will wind up this session. Next class we will complete exercise 12.2. So till then, take care of yourself. Jai Hind. Thank you.